This is R.D. Sharma's solution class 12, chapter 12, higher order derivatives. MCQ multiple choice questions we are taking. If y is equal to sine inverse x to the power square, then 1 minus x square into y2 is equal to y2 corresponds to d2y by dx2. So we have to do the double differentiation. And what are the options? One of them has to be true. So the exercise previously we have completed, we have already done this type of question. For the sake of completion, y is equal to sine inverse x to the power square. So dy by dx is going to be equal to, it is actually equal to y1 or y prime y dash. So 2 sine inverse x, and then differentiation of sine inverse x is going to be 1 by under root 1 minus x squared. Then the double differentiation. So we have sine inverse x divided by under root 1 minus x square. 2 I'll take later. So y2 we are going to do d2y by dx2 it is. So we will use the quotient rule, p by q form. So the denominator will be squared. It will be only 1 minus x square. And then we have under root 1 minus x square. Sine inverse x will be 1 by under root 1 minus x square. So this is sine inverse x. Minus sine inverse x will be like that only. And we'll do the differentiation of 1 by under root 1 minus x square. Since 1 by under root 1 minus x square have been discussed and done quite a lot for a while, so I'll directly write the result, negative x by under root 1 minus x square. This negative will become plus. So sine inverse x by under root n minus x square into x. This gets cancelled. 1 by under root 1 minus x square gets cancelled with under root 1 minus x square. Only 2 will remain because 2 was already outside and I have multiplied this inside. And this under root 1 minus x square is there. 1 minus x square is also there. And there is a 1 minus x square below the 2 also. Because when you multiply 2 with 1, it will be 2. And the denominator has 1 minus x square already. So just put this 1 minus x square in the denominator. And we have 2 by 1 minus x square plus 2x into sine inverse x divided by under root 1 minus x square into 1 minus x square. So I am taking 1 minus x square everywhere for multiplication. So this y2 will come up with 1 minus x square. All the 1 minus x square in the denominator on the right hand side will get cancelled. So you have 2 plus 2 into x into sine inverse x by under root 1 minus x square. Now if you remember, y1 was 2 sine inverse x by under root 1 minus x square. We already have. If you exclude x from here, then the other thing will be y1. So essentially this is x into y1 only. So x into y1. y2 into 1 minus x square is equal to 2 plus y1x. So this is your answer. This is your final answer. Respective option you may choose. Y is equal to e tan x, then cos square x into y2. So for the reference I have provided the solution, but we'll do it, and most of the time the solution which I provide is different from the solution I give for reference. So let us see. There may be multiple ways to solve it, but the solution or the result has to come in one of the 4 options. So y is this one, dy by dx, that is y1 we are calling it, is e to the power tan x, and differentiation of tan x is going to be sec square x. Now y2, so we have 2 terms here. This is the first term, this is the second term. So this y1 we are going to reuse. So please remember, e raised 10x into sec square x will be reused just now. But we have to now do the product rule. E tan x to sec square x will be sec x, and then sec x differentiation will be sec x tan x. Then we have plus sec square x, and e tan x, e raised tan x will be e raised tan x only, and tan x will be sec square x. So this has already been done. So now this can be termed as y1, but not now. I'll just look for the first term also, then we'll do the changing or the replacement. Now this is sec square x. You can take the sec square x common from both the terms. What will be remaining? 2 tan x, e raised tan x, plus this will come outside. We have e tan x and sec square x. Now you might be tempted to ask that why are you not taking e raised tan x outside? Because e raised tan x into sec square x is already y1. Okay, and this e raised tan x into tan x, so we can just change this also, the first term also. I'll just show you. But whatever is required, this sec square x will go to cos square x when we transfer it on the left hand side. So because sec square x is essentially 1 by cos square x, and we cross multiply it is going to be cos square x by 2. This is going to be this plus e tan x into sec square x was already y1, as I showed you that we are going to reuse it. Now here we have to change certain things. See, only if I multiply this with sec square x and divide by sec square x, because sec square x into e raised tan x is y1. So I'm multiplying here the first term with sec square x in the numerator denominator. So when you do this, you'll see this whole term e raised tan x square x is what? Y1. You can replace it by y1. And what is remaining? 2 tan x into divided by sec square x. That we are going to do just now. So 2 sin tan x will be sine by cos, and cos square if it goes, sec square is if it goes up, it is cos square. So you can just cancel this. 2 sin theta cos theta, 2 sin theta cos theta is sine 2 theta. So it will be sine 2x. So you can write it as sine 2x. You have y2 cos square x is required on the left, so right will be y1 into 1 plus sine 2x that we have as an option C in this particular question. Next is y is equal to ax plus b divided by x squared plus c, then 2x y1 plus y into y3. y3, that is, we are going to differentiate it thrice, 3 times, and we'll do the, we'll follow the natural course of differentiation. Y is equal to ax plus b by x squared plus c, and the best thing to do is using the p by q form, that is the question form, but you may also do it with cross multiplication. That is, x square plus c can be brought on the left hand side with cross multiplication, and then ax plus b will remain on the right hand side, and now you can proceed with your differentiation in the form of p dot q, that is the product rule. So x square plus c we have dy by dx plus y will be there, x square plus c differentiation will be 2x, and this is going to be equal to what? This is going to be equal to ax plus b, and ax plus b differentiation is only a. So this is y1 differentiation is dy by dx, so we may reuse the content in the later part. And this x square plus c into dy by dx differentiation, dy by dx you can write it as 1, it will be easier for the later part. Okay, left hand side, x square plus c. So x square plus c dy by dx will be d2y by dx2 plus dy by dx, and x square plus c differentiation will be 2x plus. Now we have 2y into 2x, so you can have 2xy. Now we are differentiating x and y. Remember, we are differentiating with respect to d by dx, that is with respect to x. So xy differentiation will be what? 2 will remain there, we'll use it later. Differentiation of x by x, this dy by dx plus y, d by dx of x is 1. So we have x into y1 plus y. So just multiply with 2. You have 2y plus 2x dy by dx. So 2y x square plus c d2y by dx2 can be written as y2 plus 2x dy by dx can be written as y1. Then we have 2y we have already written on the first term, and we have 2x dy by dx. This already done. 2x dy by dx you can write it as 2x into y1. 2x into y1, and everything on the right hand side is 0 because differentiation of a we have already done and it is 0. So we have a 0 here. This has come. This is an expansion. Now just add these two whichever are possible. 2y into x square plus c into y2, and 2x y1 plus 2x y1 is 4x y1. Okay. Now since it is asking for y3, so we have to differentiate it again. 2y differentiation y1. Now 4 into x y1. Differentiation of x y1 will be what? X y1. So x y1 will be y2 plus y1, and differentiation of x will be 1. So you can write it as 4x y2 plus y1. Now again here this can be done in p dot q form, product rule. So I'm doing it here, x square plus c, y2 differentiation will be y3. Then we have y2, and differentiation of x square plus c will be 2x. This will be 2x y2 and then y3 into x square plus c, and that is going to be equal to 0. Okay, let's open it. 2y1, it's not y, 2y1. 4x y2 plus 4y1 plus 2x y2 plus y3 into x square plus c. Okay, remember we are going to replace certain thing, as I told you that this x square plus c has to be eliminated in the terms of y and x, or y, y1, y2, y3x. So 4x y2 plus 2x y2 is 6x y2, 4y1 plus 2y1 is 6y1, and it is okay. Now this y3 into x square plus c. X square plus c can be computed or can be replaced by what we have done earlier, because we are requiring with y3 in the question 2x y1 plus y, from where we are going to get this y3. X square plus c, there is a step which we just have seen, that 2y plus 4x y1 plus x square plus c into y2 is equal to 0, and from here we can eliminate this x square plus c with the terms having y, y1 and y2 and x. x. So this particular line, this particular step, it will be used for the replacement. How we are going to use the replacement? See, x square plus c, 2y here. So you can just x square plus c into y2, you can just take minus 2 on the right hand side, minus 4x y1 on the right hand side, and y2 in the denominator. Now you can replace the x square plus c as minus 2y minus 4x y1 by y2. So I'm replacing this by minus 2y minus 4x y1 into y2 is equal to 0, right? Now we have come up with a certain, because 2x y1 plus y into y3 we have got, but there are still things remaining because this is 2y minus 4x y1. So what to do is, this y2 has already gone, this 2y multiplied by y3, okay, y3 is already there, you don't have to multiply, but it is still there. But you can do one thing, you can just multiply this and then do it later, because we are going to divide it by 2, because we don't need this minus 2y1 minus 4x1, or you can say 2y plus 4xy1. We need 2xy1 plus y. We need 2xy1 plus y. So let us divide 2 with everything. When you divide 2 with everything, I'm taking just this 2y minus 2y minus 4x y1 y3 I can take on the right hand side. When I take it on the right hand side, it will be pretty easy for me to divide everything by 2, and when we divide it by 2, you will get on the right hand side 2xy1 plus y into y3, which is intended in the question. So I'm just dividing everything by 2. So it will be 3y1, 3y1 y2, 3x y2 square, and since here this is what is required, so you can divide it by 2 and taking on the right hand side as I just suggested. So it will be y3 on the outside, it will be y plus 2x y1. Now y plus 2x y1 into y3 is being required in the question, and that is, if you take the left hand side of this, you can take 3y2 common here. You have y2 here, you can take just 3y2 common. And when you take 3y2 common, you will see that it's going to be 2x y1 plus y into y3. Okay, so this is going to be your result, 3y2 into y1 plus xy2. So I'm just taking things common. You know it very well, because it's just taking common and making it relate to the options being given in the question. So 2xy1 plus y into y3 is essentially equal to the option A, which is y1 plus xy2 into 3y2, and that is going to be your answer. That is what you are going to tick or choose in these multiple choice questions, right? Now this y is equal to log x by a plus bx to the power x. Now this power x will certainly come in the front, okay, because it is y log x. It's y is equal to x log x by a plus bx. Let us differentiate it. Dy by dx is going to be equal to, see, this is y1, you can write it as y1. This is going to be equal to log x by a plus bx. Differentiation of x will be 1 and plus, now x will be there. Now we'll differentiate log x by a plus bx. So the 1 by of this is reciprocal of this, a plus bx by x, and differentiation of x by a plus bx, this is going to be a plus bx whole square, it is going to be. Then we have a plus bx here, differentiation of x will be 1. Now minus x here, and a plus bx differentiation is going to be b only. So numerator is going to give you in this step, let me write it everything first. Log x by a plus bx, and x can get cancelled with this. 1a plus bx gets cancelled. A plus bx minus bx is going to be bx gets cancelled. You have a plus a by a plus bx. This is your y1. For the reference, I'm just giving you the solution. This y1 we have already achieved. Now this is your 1. Now a by a plus bx is going to reappear, so we need to replace it. So let us do it here only. If in this log x by a plus bx, if I multiply x and divide by x, then x into log x by a plus bx will be what? It will be y. So this whole is going to be, why I'm introducing x in the numerator denominator, then only it will come. So it will be y by x plus a by a plus bx. On the left hand side you have a y1. Now take this y by x on the left hand side. y1 minus y by x is equal to a by a plus bx. So y1 minus y by x is equal to a by a plus bx. We are going to utilize in the later part. So you can call it as whichever number you want, but this is going to be utilized in a short while. Now y1 was already done. This one, y1 was already done. Now we are going to differentiate this y1. Okay, we are going to differentiate y1, which is equal to log x by a plus bx plus a by a plus bx, which we actually got. X by x, which we introduced, we are not going to use that. That was only done to tell you to show you that a by a plus bx has to be replaced by x, y1 minus y by x, and how has it come. That is the only thing which we have done. So this differentiation we have already done, log x by a plus bx, if you remember, while we were doing the product rule for x into log x by a plus bx. Okay, so let us differentiate this y1, which is log x by a plus bx. It is going to be a plus bx by x, a plus bx by x, and in the numerator only a, and denominator we have a plus bx. Remember, a plus bx, so we can just cancel this out. And then we have in this a by x into a plus bx. Now we have done this differentiation. Now this differentiation will be done. Since it is a constant, you can just write a like that. I'm not writing this sign because definitely it is going to be negative, because we are going to differentiate 1 by a plus bx. A plus bx will go in the numerator, a plus bx to the power negative 1, negative. So when you differentiate, negative will come in the numerator, minus a plus bx minus 2. A plus bx differentiation will be b. So it will be minus a, we have a plus bx to the power square. This b will come here. Okay, now so we'll take the LCM first and we'll try to resolve it so that we come up to a by a plus bx, which we did already. So I'm taking the LCM. It's going to be a into a plus bx in the numerator for the first term, and it's not a plus b, it's a plus b bx. Sometimes I just forget certain things, and if you're following, you know that what we are doing right. Minus abx, so we have just multiply this, a square plus abx. We already have a minus abx. You can cancel these out, only a square will remain. So what do we get here? We get y2 is equal to, we have a square by x into a plus bx whole square. Now if you remember, a by a plus bx whole square is x y1 minus y by x. I told you that this is going to reappear. We actually did certain things to make it appear. So a by a plus bx can be replaced by x y1 minus y by x. Since it is square, we are replacing it by square. So x y1 minus y by x whole square it will be, and you have a denominator in the x, so you can write it as x y1 minus y whole square by x cube, because x square was already there, x was there. So we have now x3 take on the left hand side. So it is going to be x cube, x3 is x cube into y2. That is what is asked in the question, and this is equal to x y1 minus y whole square. Remember? So x y1 minus y whole square is x cube into y2. We did everything to get x cube and y2 on the left hand side, and whatever comes on the right hand side, that is going to be your answer. It can be x y1 minus y whole square. It can be y minus x y1 whole square, because it is square essentially. Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.